The sea rages. Wind howls with a force that stings the skin. Darkness blots out the rising sun. It is 10,500 BCE. The coastline of Doggerland, an ancient land now sunken beneath the North Sea, trembles. A monstrous wall of water roars. It slams into valleys and forests at 70 kilometers per hour. Salt spray fills the air. Temperatures hover near 6 C. The current rips trees from the earth. No warning, no escape, no mercy. A modern human would last perhaps hours here, shivering and helpless. The waves strip land bare in minutes. Ancient people stand little chance. And yet, bones, tools, and campsites prove that they returned, adapted, survived. They had no smartphones, no sirens, no scientific forecasts. So how did ancient people survive deadly tsunamis without modern technology? The popular image is chaos. Screaming crowds running for high ground, swept away. Hollywood gets it completely wrong. Archaeological evidence paints a subtler picture. At Agios Petros in Greece, at Ertebølle on the Baltic, even at Minatogawa in Japan, settlements appear right in tsunami zones. These sites date from 12,000 to 6,000 BCE. Some show entire villages rebuilt after waves flattened the old. Artifacts prove sophistication. Tools, shelters, cooperation, often using techniques that would impress modern engineers. The answer is not luck. It is innovation. At Çayönü Tepesi in southeastern Turkey, dating to 8,600 BCE, archaeologists uncovered circular stone platforms. Each sits 6 meters above the current river floodplain. Deep post holes show houses once raised on stilts, some reaching almost 2 meters above ancient soil. Tsunami debris embedded in clay layers proves that water inundated the region repeatedly. At Tohoku's Jōmon site in northern Japan, around 6,000 BCE, stone-lined ditches snake between shell mounds. Excavations reveal identical patterns. Villages flee to ridges, then return, rebuilding on low platforms of gravel and wood. In one pit, ocean sediment, rich with diatoms, rests directly beneath hearthstones. Ertebølle in Denmark, date 5,400 BCE. Archaeologists recorded more than 70 distinct habitation layers. Some contain mixed river and saltwater sand, fish bones, and burnt post stumps. Yet the settlement kept growing, with newer houses set 20 meters further inland each century. But here's what made researchers gasp. At Minatogawa in Okinawa, 7,000 BCE, preservation of seaweed mats and woven cord hints at emergency rafts, stored above flood lines. The evidence stacks. Platforms, ditches, rafts, and flexible settlements. Pattern, not panic. Survival, not scatter. These ancient societies were not waiting for disaster. They built for it, again and again. But how did they stop the water from sweeping everything away? The answer lies in elevation. Raised earth mounds, stone platforms, and stilted homes. At Çayönü Tepesi, mud brick and timber houses stand on pedestals. Archaeologists measured the average stilt. Height, 1.8 meters, well above historical flood marks. Circular pads of river stone anchor each pillar. The science is simple. Water flows under, not through. This wasn't basic shelter. It was adaptive fortification. Excavators from the Istanbul University Museum identified diagonal bracing beams placed at 15-degree angles, distributing the impact of surging water. Modern experiments at the University of Exeter's Disaster Lab tested similar stilt homes. Result: these structures survived simulated waves twice the impact force that flattens standard ground houses. But elevation didn't just save buildings, it saved lives. In Tohoku, villagers built ladders of tied driftwood that allowed rapid evacuation upward. Floors had trapdoors, quick exits to the roof. Some pads even used woven reed skirts to deflect waterborne debris, much like breakaway fencing today. The engineering principles echo modern Japanese tsunami design: breakaway panels, floating foundations, and resilient uprights. Yet there was an added benefit. Stilted homes kept out snakes, biting insects, and ground damp year-round. Multi-use resilience. Where today's beach towns risk total loss, these ancient systems convinced entire communities to rebuild, not retreat. They adapted architecture to the ocean's fury, but strong stilts alone do not withstand the ocean's power. How did they keep homes intact? The answer? Material technology. At Ertebølle, archaeologists uncovered thick mats of woven willow and birch bark layered beneath clay floors. Radiocarbon dating, 5,200 BCE. These composites shed water and resist rot, nature's version of waterproofing. Average thickness, 2 to 4 centimeters per mat, pressed and replaced yearly. Minatogawa's miracle, seaweed cordage, knotted in repeating patterns, strands of sargassum and kelp braided with animal sinew. This rough rope stays flexible when wet, yet tightens under strain. Tests at Okinawa Prefectural Museum show tensile strength holding up to 170 kilograms, greater than modern garden rope. At Mohenjo-Daro, on the ancient Indus, brick and lime mortar built retaining walls. Measurements, some blocks up to 40 centimeters thick. Close analysis from the British Museum's collections shows brick alignments angled seaward, channeling floodwater out. These ancient walls compare favorably to today's reinforced seawalls for small-scale events. Yet water-resistant technology didn't end with building. Residents at Çayönü used birch bark caulking to seal baskets, keeping grain and seeds dry. Some sites reveal pitch-sealed pots. Multiple lines of evidence, natural composites, engineered alignment, sealants. Modern engineers still seek organic, biodegradable waterproofing. It worked then, outlasting centuries. Each layer, mat, and mortar join tells the same story. Intention, knowledge, continuity of technology. Ancient people invested labor where it mattered, keeping water out, survival in. But even the strongest shelters need environmental control. How did they slow deadly waves before they struck? The answer is landscape manipulation. At Doggerland and Jōmon coastal sites, ancient engineers created intentional buffer zones. Thick bands of willow thickets, driftwood berms, and piled stone barriers line many ancient shorelines. Analysis at the Natural History Museum, London. Sediment cores show packed root layers up to 1 meter thick. At Tohoku, villagers redirected small rivers to form marshy wetlands, nature's sponge. These areas absorb and disperse water, reducing tsunami surge by up to 40%, per University of Tokyo hydrological models. Canals just 50 centimeters wide slowed saltwater intrusion after wave events. At Ertebølle, oyster shell piles rise between houses and open sea. Some formations stretch 40 meters long, 4 meters wide, and 50 centimeters high. While once thought to be refuse, new studies see them as storm barriers. The shells interlock, dissipating wave energy, and create elevated ground. The science is counterintuitive. You fight water with nature, not concrete. Modern coastal ecologists now recommend replanting mangrove, willow, and loose rock for flood control. Satellite imagery of Sumatra's 2004 tsunami. Villages hidden behind natural buffers survived, while those with bare coasts vanished. These ancient interventions did double duty. They provided firewood, food, and building materials, all grown in defensive bands. Human hands shaped land, transforming high-risk coastlines into layered fortresses against the ocean's wrath. This was living engineering, updated every generation. But no house or barrier can guarantee safety. So how did communities respond together? The answer was tightly organized social systems. Archaeology reveals complex community layouts and disaster routines. At Çayönü and Ertebølle, settlement plans show clustered family units. No structure stands more than 30 meters from the next. Central clearings act as gathering zones. In Jōmon, Japan, clusters of roundhouses encircle communal fire pits, always with clear escape routes inland. Analysis by Kyoto University mapped these routes as paths 10 meters wide, lined with stones. Excavations at Minatogawa found granaries and supply storerooms perched on higher ground, always accessible within minutes. Oral tradition, inscribed on tablets much later, recalls 3 drumbeats as the alarm. Family councils rotated roles: watch, gather, warn, and carry essentials. The science is clear. Group drills raise survival rates. Modern disaster researchers at Sendai replicated ancient evacuation drills. Time to high ground, less than 8 minutes for practice groups. Random, untrained groups performed no better than solitary individuals. This wasn't simple kinship. It was coordinated protocol. Sleeping patterns shifted in storm season. Children shared beds with elders for speed. women and men posted alternating. Night watches. Before the wave struck, essential skills synchronized. Warning, mobility, and care for the vulnerable. The village as organism, its nervous system primed to sense and react. Social bonds here are as critical as stone or timber. Human network, human memory, the first warning system. But survival demands more than safety. What about food when the landscape floods? The answer, proactive management. At Ertebølle, granary pits dug 2 meters into sandy soil preserve cereals and acorns, sealed with clay and arched willow. Dated grains, 5,100 BCE. Volume per pit, over 200 kilograms, enough to feed a small band for weeks. At Tohoku, drying racks of woven reeds lined shelter eaves. Archaeologists counted over 150 fish vertebrae, smoked, dried, and stacked in waterproof pouches. Caloric analysis. Each rack stores up to 20,000 calories, critical insurance after crop loss. Coastal groups elevated stores on tripods, protected from vermin and flood. In Doggerland, isotopic testing of human remains shows high marine protein intake, but also varied diet, hazelnuts, roots, and wild game. Preservation was key. Pit ovens, stone-lined, clay-capped, could cook and smoke large hauls of shellfish. Remnants at the London Natural History Museum show oily residue, suggesting preservation for up to 4 weeks. Modern disaster planners envy these systems, redundant, decentralized, rapidly deployed. Where modern towns bottleneck around grocery supply, these ancient groups distributed food over distance and time, limiting loss. Every family, every group practiced techniques that ensured continuity. Resource management wasn't backup. It was culture, tied to ritual, calendar, and collective memory. No single meal stood between life and death. Communities were buffered, organized, and always ready. Modern archaeologists and engineers have put these ancient tactics to the test. At the Tsunami Research Center in Tohoku, researchers reconstructed Jōmon period stilt houses using only wood, reed, and stone. Simulated wave surges at 80 kilometers per hour targeted the models. Performance? Minimal damage. Upland storage survived. Foundation mats flexed, not snapped, outperforming several conventional concrete models. At the Ertebølle experimental village in Denmark, heritage scientists rebuilt shell dike and willow barriers along the restored Baltic shore. In 2021, storm waves battered the site. Yet the oyster shell dikes and planted reeds absorbed up to half the impact compared to neighbouring unprotected plots. Sensors recorded ground vibration reduction of 45%. University College London coordinated multi-country studies in experimental archaeology, large-scale storage pits, stilted granaries, seaweed cordage, and trapped air heating, all recreated. Across every category, ancient designs performed no worse than modern equivalents, and often better for local, low-energy conditions. Modern engineers studying organic. Sealants found birch bark and pitch as water-resistant today as proprietary synthetic materials. Preservation of food in pit ovens equaled or exceeded modern ambient drying racks. Even disaster planning, when compared to digital alert systems, found community drills resulted in faster response than alarms among untrained groups. The verdict: the ancient wisdom works. When scaled with local labour and resources, results rival 21st century disaster mitigation. The past offers not just lessons, but blueprints. The technologies forged in tsunami shadows changed human destiny. Elevated homes enabled people to recolonize risky coasts. Composite building bands diffused inland, becoming defensive ditches, then city walls. Social protocols matured into councils, then law. These innovations migrated, from Doggerland to the Thames, from Jōmon, Japan to the Pacific Rim. Maritime storage, landscape management, and communal warning systems spread across cultures. Trade routes became conduits for knowledge as well as goods, but much was lost. The rise of states and central religion replaced communal warning with authority. As towns built higher walls and artificial harbours, the subtle art of organic resilience faded. The abandonment of these techniques represents a disappearance of wisdom, local, even intimate, in its understanding of land, life, and water. Yet traces survive. The stilt villages of Southeast Asia, the oyster reefs of the Gulf Coast. In every place where sea meets settlement, glimpses of the ancient dance endure. Our survival as a species owes as much to these unsung inventions as to any king, stone monument, or conqueror's legacy. Their silent story is the story of us. It should have been impossible. Tsunami waves as tall as buildings. Storms colder than the heart of winter. No warning, no rescue, no second chance. Almost anyone would fold under such threat. But these ancient people didn't just persist, they innovated. With their bare hands and sharp minds, they turned disaster into design. They created elevated homes and stilted shelters to ride out the worst storms, water-resistant composites of reed, bark, and cordage to defend against the sea, living barriers and managed landscapes to blunt the waves, social warning systems and drills that saved precious seconds, redundant food logistics to stave off hunger. When everything else washed away, far from primitive, they were accomplished engineers and survival scientists. The next time you check a weather report or receive an emergency alert, remember that ancient people survived the world's wildest tempests with only wood, stone, and wisdom. Their legacy lives on wherever humanity stands between land and sea, defiant, ingenious, and determined to endure.